This video is all about angle bisectors. So angle bisectors is a nice little review for us. But now we're going to add a couple little things to it, right? So angle bisector is going to be a ray or a segment or a line that is bisecting an angle. So we have here, I'm going to label these A, B, C, and I'll put D, E, F. Okay, so we have here angle CAB is being bisected by ray AE. So that means these two angles are going to be congruent. Okay, we also have angle ACB is being bisected by ray CD. So those two angles are congruent. And then again, BF is bisecting angle ABC, so those two angles are congruent. Now, the biggest mistake people are making is they are not labeling the angles when they are being bisected. Label, label, label. I promise it will help. So here, this angle is bisected, so that means it's congruent. So let's say this angle was 30 degrees, and this is 30 degrees. Okay, they would both be the same. So that means the entire angle, so the measure of angle CAB would equal 60 degrees. Okay, next, let's go ahead and let's say that this angle C, this angle, sorry, not angle C, angle ACB. If I said the measure of angle ACB was 40 degrees, that entire angle is 40 degrees, that means that each little angle is 20 degrees, 20 degrees. So all of them are going to have that same degree. Now, what if I said, okay, with the information that you have here, what is the measure of angle ABC? What is the measure of that? What is the measure of angle ABF? Well, first you would have to go ahead and do 180 minus 40 minus 60, and we would get 80 degrees. So left over, we have 80 degrees, so we know the entire angle is 80 degrees, but each angle would be 40 degrees because they are congruent to each other. They are congruent to each other. Okay, so angle bisector, you're going to get the angles congruent. Now, angle bisector is going to have a point of concurrency. It is in the center. So let's say this is point R. Point R is the point of concurrency, and it's called the in-center. The in-center, and it'll always be inside of the triangle, hence in-center. Think of it always inside. Some things that we know about an angle bisector is the in-center is equal distance from the sides. Okay, so the in-center, R, is equal distance from the sides. So the side, this is the side. So here's the side, okay? RD, and then RE. So all of those are going to be congruent. So we have RF and is congruent to RD, which is also congruent to RE. Those are all congruent. The next says, of triangles equal is perpendicular line is dropped. Okay, so the triangles will be equal if a perpendicular line is dropped. So let's say here that this angle bisector AE was not just an angle bisector, but also was an altitude, okay, plus the perpendicular bisector. That means if it was the altitude and perpendicular bisector, you would get those congruent, so you would get CE congruent and EB congruent and the right angle, giving us congruent triangles. So triangle ACE would be congruent to triangle AEB, but again, only if we have that additional information. Only if we have this additional information. Now, as you see here, I've gone through all four of these special lines that we have now drawn. You can have multiple in a triangle. You don't have to just have one type. You have to be able to know which is the point of concurrency and what to do with each of these here. And if you have multiple listed, you have to know exactly, okay, use these different pieces of information and these concepts to help find the missing information, knowing the specific line you have. All right, thanks for listening.